Alright, so I understand that you guys are needing some extra help with nomenclature. So I'm going to talk you through some information about that, and doing it a little bit different so that hopefully it is easier to kind of view than an educreation might be. Alright, so it sounds like most of you guys are pretty good with the basic problems. So for instance, the basic ones would be binary ionic compounds. So where you have two different elements like NaCl. So the first one keeps its name just as it is, so that would be sodium. The second one we changed to the IDE ending, so that would be chloride. Alright? And if we're going backwards with these, let's touch bases on that just momentarily to make sure that you've got that. So for instance, if I gave you calcium oxide, alright, and we look these up on the periodic table, so that's kind of our first step, and we find what their oxidation numbers are. So calcium has an oxidation number of +2, and oxygen has an oxidation number of -2. Alright, so our rule of thumb is if the oxidation numbers are numerically the same, because there's always going to be a positive one and a negative one, but if they're numerically the same, then we simply get one of each in our compound. So our compound becomes CaO. Now, if our compound is not numerically the same, like for instance if we had potassium sulfide, alright, and we look these guys up on the periodic table. Potassium is a +1, whereas sulfide is a -2. So this time they are not numerically the same. I have a 1 and I have a 2. And this is where we do the switch. So the number for potassium becomes the subscript for sulfur, and the number for sulfur becomes the subscript for potassium. So we end up then with K2S. Alright, so those are our binary ionic compounds. Now, a lot of you sent me questions about the Roman numeral ones. Alright, so first of all, we need to understand that our Roman numerals take place with our transition metals and lead and tin. So kind of as a rule of thumb, if they fall into that transition metal family, then they're probably going to need a Roman numeral. Now, there are a couple exceptions. And the two main ones that you guys are going to need to know is zinc, which is always a +2, and silver, which is always a +1. So those two don't require a Roman numeral. If you were to write a Roman numeral N, then it would be okay. You wouldn't get points taken off. But all transition metals and lead and tin require Roman numerals. So when you're looking at a formula, if you look on the periodic table and it's a transition metal, then you just want to think, I need a Roman numeral. If it is lead or if it is tin, then also you want to think, I'm going to need a Roman numeral. So let's look at a few of these, for instance. All right, so let's say we have, let's do iron. So for instance, if we're starting off with naming these guys, and we have FeO. All right, now one thing when it comes to naming something with a Roman numeral, obviously we have to figure out what its Roman numeral needs to be. And we're going to do that by looking for subscripts. So for instance, this one here has no subscripts available. So in order to figure out what iron is, we have to look up oxygen. So we know that oxygen's oxidation number never changes, and so that means it's always a -2. And the rule of thumb was, when we don't have subscripts, that the oxidation values were the same. So that means if oxygen is always -2, then iron must have been a +2 in order for there to be no subscripts present here. So when we name it then, that means that this becomes iron. The Roman numeral is our oxidation value. So this is iron 2. And oxygen becomes oxide. All right, let's look at the other version of iron. So we have Fe2O3. So this time we do have subscripts present in our compound. And just like when we were writing the binary ones and we were talking about how we got subscripts, those subscripts came from us switching the oxidation values down to become a subscript. So that means that this 2 actually was oxygen's oxidation value, which we know is correct because oxygen is -2. So that means that this 3 right here was iron's oxidation value. So we named this one iron 3 oxide. All right, let's look at a few more. Let's say we had SNS. All right, so again, this is tin. Tin is not a transition metal, but it is one that will require Roman numerals. The first thing we're going to do is look and see if there are any subscripts present. No subscripts present, so we're going to have to look up whatever sulfur's oxidation number is. So we look up sulfur. Sulfur is a -2. So then we can conclude then that tin must be a matching with a +2. So this would be 10, 2, sulfide. All right, let's say we had PB3N4. So PB is lead, again one that requires a Roman numeral. So we look, do we have subscripts? Yes, we do. So we know then that all we have to do is switch them back. So 3 belong to nitrogen, whereas 4 belongs to lead. And therefore, our written out words here would be lead 4 nitride. Alright, so it's important that you understand how to figure out which ones need Roman numerals and which ones don't, because you're going to get a mixture. So they could all just be thrown in there together. Like for instance, if you had SrCl2, alright, so we look up Sr. Sr is strontium, and strontium is an alkaline earth metal. Well, an alkaline earth metal always has the same oxidative state, and it's always a +2. So that means it doesn't require Roman numerals, so we just name it as is. So this would be strontium chloride. Alright, and you do need to be able to tell the difference, because if it does not require a Roman numeral, such as the alkali metals or the alkaline earth metals, or some of those metals that we have that are over here on the periodic table, these guys right here, except again for lead and tin, alright, like aluminum, gallium, germanium, those guys don't require Roman numerals either. And so if you were to write them with one, they would be counted incorrect. Alright, so let's go from the name to the compound. Now with Roman numerals, these are actually a little bit easier. So for instance, let's say we had copper 3 fluoride. Alright, so I'm going to do a preliminary step in between. It just helps me be able to see what I'm doing. And that's, I'm going to write the symbols with their oxidation states before I write my final compound. Alright, so copper is Cu. Alright, its oxidative value is in parentheses there because it is a transition metal. So it has a +3. And then fluoride is fluorine, and I would have to look that one up. So fluorine has a -1 oxidation value. My oxidation numbers, alright, are different, which means they're going to switch. So my final answer then would be Cu1, and we don't write the ones in, F3. So this is the actual answer. Now you want to make sure you don't put any positives or negatives into your final answer. Let's do another one. Let's say we had tin for bromide. Again, I'm going to do the preliminary step just so you can see